Hello students. Today our chemistry topic is classification of elements and periodicity properties. So first, what is element? So group of atoms. Atoms are fundamental particles of the matter. So they are in same form together, that is called elemental form. So many elements there, yes or no? Elements are more. So 110 elements are known for us right now. So among these are 90 are natural elements and remaining are man-made elements. So all elements we have to read at a time, it is impossible. So required to classify them. So classification is very compulsory for elements. By classification only we read them easily and understandable. Okay, so required here classification of the elements. So for this lesson for JEE Mains, one question is compulsory question is that regarding the periodic properties of the elements. So download our app for great discounts on our courses also available. Courses offering JEE, Eamcet, NEET. Daily preparation there, subject wise content there, study material also available. Now our parameters, free handwritten notes, free study material, previous year questions, free mock tests available. Now come to our topic fundamentals. So how many elements present? 110 elements are present. In that up to 90 they are natural. And above 92, atomic number above 92. Otherwise, after coming atomic number 92, they are called transuranic elements, synthetic elements, man-made elements or radioactive elements. So who was the first scientist attempt to classify the elements? Dobereiner. After Dobereiner, Newlands, Lothar-Meyer, they were classified elements and shown their periodic tables. But after them, the great scientist Dmitri Mendeleev classified elements. So it is called Mendeleev classification of the elements. So what is the main fundamental property of the Mendeleev classification of the elements? So Mendeleev classification of elements main base is atomic weight, atomic mass. But this periodic table depends on law. This law is called periodic law. The physical, chemical properties of the elements or periodic function, that is depends on their atomic weights. So I say here atomic weight is the fundamental property of Mendeleev's periodic table or classification of the elements. Now Mendeleev periodic table also known as short form of the periodic table. Yes, it has the similar properties we observe in that. In that, what is the main point? Almost have same atomic weight. So atomic weight is the fundamental property. But in that see here iron Fe, CO cobalt, Ni nickel, their atomic weight similar. Next, atomic weights increasing constantly. Potassium 39, rubidium 85, cesium 133. So atomic mass is the main base in this Mendelic periodic table, and in that few elements they have nearly same atomic weight. This atomic weight is increasing. If see the one by one element atomic weight is increasing. Now we focus on the Mendeleev classification of the elements. So Mendeleev classified elements, and in that is shown in the form of the groups and periods. First we see the periods. What are periods? See this figure. In that, okay, horizontal rows. So in that some rows, these are horizontally, okay, present. These are called periods. So how many periods there? 1, 2, 3, 4, 5, 6, 7. So in Mendeleev periodic table, how many periods? 7 periods are available. The first 3 periods are short periods. See, period number 1, S. Now what about period number 2? Period number 3. First 1, 2, 3 periods, they are short periods. Yes. After period number 4, 5, 6. Yes, see. So first 3 periods, they are short periods. Yes, because they are contain less elements. Compare with 4th one, 5th one, 6th one. Yes, clear? Now, see the first, second, third periods are, yes, they are short periods. And see the 4th period, this 4th period again divided into sub periods. So this is the 4th period A, B. Same way, 5th period also divided into 2 subgroups. 6th period also here divided into 2 subgroups again. Okay, it is the structure of periods in Mendeleev periodic table. Total how many periods present in Mendeleev periodic table? 7 periods present in Mendeleev periodic table. In that how many they are short periods? Period number 1, 2, 3 they are called short periods. Period number 4, 5, 6 are called long periods. Period number 4, 5, 6 they are again divided into 2 sub-series. Yes. Question. So, what are the Mendeleev periodic table periods? They divided into subgroups. Okay, period number 4, 5, 6. So, period number 4, 5, 6 in Mendeleev periodic table, again they are divided into, yes, okay, sub-periods. Clear? They divided into here again sub-periods. Clear? Yes. Up to here, any doubts there? Up to here, any queries? No. Now see, after learning what periods, now we see the groups. So what are groups in Mendeleev periodic table? See, horizontal columns. Vertical columns. These vertical columns are called groups. See how many groups there in Mendeleev periodic table. First group is 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 0. Total how many? 9 groups present. Okay. 8 plus 0. Total 9 groups present in Mendeleev periodic table. Yes. So what is the name of the first group? First group is called zero group because in that helium, neon, argon, krypton, xenon, radon elements present. Group number 1 in that hydrogen is there along with lithium, sodium, potassium, copper, rubidium, silver, cerium, rhodium, francium there. Group number 2 beryllium, magnesium, calcium, zinc, strontium, cadmium, barium, mercury, radium is present. Group number 3 boron, aluminium, scandium, gallium, okay, ytterbium, indium, lanthanum, yes, titanium, actinium present. And group number 4 carbon, silicon, titanium, yes, it is thallium, germanium, zirconium, tin, okay, osmium, lead, thorium present. Group number 5 nitrogen, phosphorus, vanadium, arsenic, niobium, seaborgium, tantalum, bismuth, Pa they are present. Group number 6 oxygen 2 uranium, sulfur, chromium, selenium, molybdenum, tellurium, wolfram, polonium present. Group number 7 fluorine, chlorine, manganese, bromine, okay, tectinium, iodine, radium, astatine present. And group number 8 they are contain metals iron, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum present in Mandelic 18th group. Now come to the group 8 in Mandelic periodic table. So in Mandelic periodic table group 8, if we check the group 8, in that, okay, these are called 3 triads, yes, because what is the meaning of triad? Triad means, okay, like Dobereiner, okay, law of triads. So in that how many? Three elements present. So these are called triads. Okay, these triads are called transition triads because in that transition elements present. What are they? See, first one iron, cobalt, nickel. It is the first triad. Second triad is ruthenium, rhodium, palladium. And the third triad is osmium, iridium, platinum. Yes. But at the time he does not, okay, predicted zero group elements. Later, okay, Ramsay and Rayleigh they introduced zero group elements. Yes. So at that time, don't know, okay, not given properly the place of the zero group elements. Later, it is introduced by Ramsay and Lehman regarding the zero group elements. Now, we see the very briefly about the Mendelic's classification of the elements. So Mendelic was very great intelligent scientist because he was discovered so many elements and classified very good manner compared with previous periodic tables. Okay, and I'm saying he was very intelligent. Why? Because he don't know some elements at the time while constructing his periodic table, but he was given gaps. Okay, those gaps perfectly they fitted after discovering the elements. Like, okay, he don't know Eka boron he was. Then he given, yes, okay, place for Eka boron. Okay, below the boron. After he don't know what germanium. So he given name for that Eka silicon below the silicon. Same, he don't know at the time gallium. He given for gallium Eka aluminium given below the, okay, aluminium. By this way, he was given gaps but don't know the names, but he given very perfectly gaps below the respected elements. Like what? Eka boron, that is scandium. Now we know. Now Eka silicon, for us known as a germanium. Same Eka aluminium, for us known as a gallium. So what is Eka boron? It is called scandium. Eka silicon, below the silicon, germanium. Eka aluminium, below the gallium, Below the what it is? Aluminium. It is called gallium. By this way, eka boron, scandium, eka silicon, germanium, eka aluminium, gallium. He was given very perfectly gaps in his periodic table. Okay, and Mendeleev corrected some elements' atomic weights before they are wrong. Before they were wrong in previous periodic tables. That is like beryllium, Be, indium and osmium. How he was corrected them? He has taken valency electrons. So valency electrons means what? Outermost orbit electrons. So outermost orbit electrons, according to that, okay, he given atomic weight is equivalent weight into valency. Okay, atomic weight is equal to equivalent weight into valency. He got the correct weight of the beryllium, indium and osmium. Yes, next, after successfully completing the Mendeleev classification of the elements or periodic table, even in that some demerits there. Okay, what are the demerits of Mendeleev periodic table? Yes. So, what is the fundamental property of the Mendeleev periodic table? Increasing atomic weight and basis atomic weight, but he placed zigzagly some elements. Okay, atomic weight one first, atomic weight less one is next. So actually he stated, okay, atomic weight constantly increasing, but sometime higher atomic weight should be first. So that indicates what? Anomalous pairs means different pairs. Okay, pairs that not given properly increasing order of the atomic weight. Like what? Argon and potassium, first one. Second one, cobalt and nickel. And third one, tellurium and ionium, thorium and Pa. These elements, okay, higher atomic weight is first. He has given. And he given the lower atomic weight elements are after the higher atomic weights. Okay, so this is the first demerit from, okay, Mendeleev periodic table. Now position of the hydrogen. Position of the hydrogen was not made clear. He given the place above the metals hydrogen place. So it is not clear in his periodic table. Most next after this Mendeleev periodic table, okay, after learning the demerits, mostly the great scientist he started work on X-ray spectrum. Spectrum is the structure of the chemical. So in that, bombarding elements with cathode rays, and they emitted respectively from, okay, and they showed frequency. So same time mostly predicted atomic number. So what is atomic number? Number of protons or number of electrons in an atom. So atomic number is given as a Z. Can be related to frequency of the X-rays emitted by using. So which are emitted. So in that, okay, he related to frequency of the X-rays with atomic number. And he said root of V, yes, root of V is equal to A into Z minus B. So where A, B are consonants, constants of the elements. So elements, consonants and frequency of the X-rays, he predicted atomic number. And he has, okay, drawn a graph, a plot of root of V against Z atomic number, that given what? In a straight line. Yes, straight line. Okay, so atomic number has provided a better basis for the periodic arrangement of the elements. So this experiment very fruitful to give the atomic number and explained the atomic number of the element. Now this is given birth to modern periodic table. So what is modern periodic table or modern periodic law? Physical and chemical properties of the elements, periodic functions of their atomic numbers. Yes. Now in Mendelic periodic table, this is depends on atomic mass. But here in modern periodic law, explaining atomic number and same time explaining what? Electronic configuration. Now this modern periodic table depends on atomic number and electronic configuration. So electrons which we fill the respective atoms orbits. So this is the modern periodic law and modern periodic table. Yes. Now this modern periodic table also called long form of periodic table, which was constructed by Niels Bohr. Yes. So this credit long form of periodic table goes to Niels Bohr, because Niels Bohr constructed this periodic table depends on atomic number and based on the electronic configuration. Yes. So it is modern periodic table. Niels Bohr mostly contribution periodic table. In this periodic table, it is like Mendelian periodic table. In this periodic table, groups present and periods also present. Yes, groups also present. Yes, and periods also present. Groups also present, periods also present, like Mendelian periodic table. Now what are groups? Vertical columns. Yes. So vertical columns, these are called what? Groups. So total how many groups there in long form of periodic table? Total 18 groups present in this modern periodic table or long form of the periodic table. How many periods there? Yes. 1, 2, 3, 4, 5, 6, 7, 8. So total how many periods there? Periods only, 7 periods only there. In this periodic table, total, yes, 7 periods there. Clear? Now, how many periods? What are periods? Just now we discussed horizontal rows. Yes. So these horizontal rows, horizontal rows are called what? Periods. So horizontal row. So period number 1. Yes. So what about period number 1? Period number 2, period number 3, 4, 5, 6, 7. So total 7 periods present. So all periods elements are arranging according to the n plus l values. What is n? Principal quantum number. What is l? Azimuthal quantum number. Yes. So in each period the differentiating electron enters into the first s orbital. Yes. And last element enters into the last electron enters into the element p orbital. So starting s orbital is there. If we see the electronic configuration of the elements, so last present in the p orbital. Clear? Yes. Now, so graphical representation we are taking now what? Periods. In periods we fill the electrons how? According to the Hauff-Bohr principle. Yes. Here we are using Hauff-Bohr principle. According to the Hauff-Bohr principle we fill the electrons from lower energy level to higher energy level. Here first alkyl metals there. We start from the alkyl metal and ends with the zero group elements or what? 18th group elements or noble elements. By this way, first we start what? From alkyl metals and element ends with the zero group elements. Zero group elements. Clear? Clear this one? Yes. Now, what are the points here we have to remember? Yes. The third orbit contain, yes. For example, orbits there. We fill the electrons into orbits. Orbit number 1, 2, 3, 4. For example, we have to remember points in the case of the third orbit contain 3s, 3p, 3d, yes. But according to n plus L values, okay, energy order, 3d comes after 4s. We thought first 4s will come. 3d comes after 4s only. Hence, according to this reason, okay, so this d block elements, okay, d orbital contain elements, they are divided into, yes, series. In that we take the 3d series. Here, this 3d series is called first series. Okay, this is called transition period series. It starts from scandium. Scandium atomic number is 21 to zinc atomic number 30. Yes. Now what about the S? What about the second? Yes. Second is 4d series. This 4d series starts from, yes, element 1 to CD cadmium. Atomic number 39 to 48. Okay, they place it in the fifth period. It is called second transition series. Because 3d series we called first transition series. This one we are calling as a second transition series. As now come to the 5d. 5d starts from lanthanum, hafnium to mercury. So atomic number 57, 72 to 80. It is called yes, sixth period. Yes, this also transition series. Third transition series. Yes. So 3, 4, 5. It is called fifth D, third transition series. And 14, yes, 4F series, fourth one. Okay, belongs to sixth period, third B group. Yes, it starts from cerium to lutetium. Actually, it is what? 4F series. 4F and one more is 5F series. So by this way, okay, 14 4F series elements belongs to sixth period, third B group. Yes, cerium to lutetium. And 14 fifth 5F series elements belongs to seventh period, third B group, thorium 92 lawrencium. But 60 series is incomplete series, and seventh period also, okay, also completed. Then the final element of the period would be with atomic number 180. Yes, 180. Yes, clear? Now we check once again the long form of periodic table. So long form of periodic table, okay, contain 18 vertical columns, which are further divided into, yes, first A, seventh A, third B, fourth B, fifth B, sixth B, seventh B, eighth B, first B, second B. Yes. And 8 groups included 3 vertical columns. Yes. So this is the S. What related to the S. And but we adapted here 1 to 18 numbering. Yes. Just now we called these groups 1 to 18. So we adapted according to the IUPAC system. Yes. So according to the IUPAC system, yes. So we have 18 groups. So first group, yes, first orbit, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Yes. And what about the second? Second enters to beryllium, magnesium, calcium, strontium, radium. So it is first group, first A, second A group. Yes. So link in description, the spark stock, see, long-term courses also available, previous year solutions also available, crash courses, full length test, study material, mock test, JEE Mains, NEET, Eamcet, IIT Foundations, okay, high quality courses with great offers and discounts also available. SC, our, yes, structure, okay, fee structure in that Okay, what are the materials available here? Okay, given here properly. Press. And admissions open. Join now. Short-term crash courses, classroom coaching, offline classes, long-term, short-term coaching, timings also given, regular coaching also available. Our two branches also there. What is the first branch? Narayanguda, and second one is Mehdipatnam. Yes. So see this number. Okay, call and enroll your admission, JEE, Eamcet, NEET. So online coaching also available. Admissions open. Join now in that. Live courses NEET 2022 online coaching. Buy now NEET 2022 online coaching, and the live course JEE Mains 2022 online coaching. JEE Mains online coaching it is, and Eamcet 2022 online coaching. Yes. So call, given the numbers, and book your or enroll for us for admission. Our video classes, see the maths on demand sessions, physics also, chemistry also. Yes. So some live sessions also given for you daily on demand, like here which one? Principles of inheritance and variation, as trigonometry, general, organic chemistry, electrochemistry, biology revision, Eamcet revision also available on daily, on demand. These are called live sessions. Now assignments every day, assignments also present, as like coordination chemistry, the student wise pending assignment is there, and electrostatistics pending. So sexual reproduction in flowering plants, electrochem revision, reproduction in organisms, thermal properties of the matter, attempted student, circles, attempted test, parabola, attempted students. So student, which exam attempted, that also given here information. Text details also present, grades also given in colors, grade A, B, C, D, E, F, and how many minutes has taken, how many marks secured, okay, average time taken, and grade, everything we give the instantaneous. S. So methodologies there, our methodologies. So basic concepts, shortcut methods, all model questions, exercise questions there, and previous year questions, chapter-wise tests, weekend test, grand test, and test analysis also available. So these are our parameters. Next, after learning these periodic properties of the elements, so now we see the what type of questions we expect in the JEE Mains. So in that first question, the basis for the classification of elements in modern periodic table. Yes. So today we learned in this session what first Mandelic periodic table, after modern periodic table, after that long form of periodic table. But here question is asking regarding what? This modern periodic table. Yes. So which one? Modern periodic table. Yes. So in this modern periodic table, what is the base? So base is electronic configuration. So electronic configuration means we fill the electron, the corresponding atoms shells. That is called electronic configuration. So what is atomic weight? Atomic weight means the weight of the atomic number and mass number. The completely called atomic weight. So number of protons, electrons and neutrons. That number is called atomic weight. So atomic volume, atomic weight is same. So what about equivalent weight? Equivalent weight means the total weight by 2. Yes. So now modern periodic table, that is in that elements are classified depends on what? Atomic number. So atomic number is not there. So atomic, with the help of atomic number, we fill the atoms electrons. That process is called what? Electronic configuration. So here electronic configuration is main base. So classification of the elements. So depends on electronic configuration. We divided elements into how many types? 4 types. Okay, S block elements, P block elements, D block elements, F block elements. So differentiating electron means last electron that enters into the S subshell. Such elements are S block elements. So whose last electron enters into the P subshell, they are called P block elements. So whose electron enters into the last shell, D subshell, they are called D block elements. So whose electron, okay, which atoms electrons, those are enters into the F subshell. So they are called here F block elements. So here on electronic configuration we divided elements, okay, S, P, D, F in modern periodic table. So we say for modern periodic table the main base is electronic configuration. So what is the answer regarding this first example? Electronic configuration. So next question. Considering the chemical properties, okay, atomic weight of beryllium was connected based on, yes, so here connected based on yes, now, okay, we see this question. Considering the chemical properties, atomic weight of beryllium was, okay, corrected based on. Atomic weight is the fundamental property of which periodic table? So atomic weight is the fundamental property of the Mandelic periodic table. Yes. So the considering physical chemical properties that depends on the increasing atomic weight, that is Mandelic periodic table. So Mandelic periodic table, okay, in that Mendelic corrected some elements atomic weight, because compared with previous periodic tables, some atomic weights of the elements wrong. So like beryllium was, okay, corrected based on. So electronic configuration at that time we don't know, because electronic configuration is fundamental property for indirectly. So modern periodic table. So valency we know that time. So valency, okay, also one reason to correct the weights of the atomic values of the elements in Mendelic periodic table. So atomic number also don't know at that time, because only the what is the answer here? Valence. So according to valency electrons, Mendeleev was corrected some elements atomic weights. So in that beryllium also present. So beryllium atomic weight is corrected by Mendeleev in his Mendeleev periodic table. So answer is valence, because with the help of valency only he was corrected the beryllium atomic weight. Now Mendeleev corrected the atomic weight of, yes, Mendeleev in his periodic table corrected some elements atomic weight, okay, with the help of valence. Okay, by that way he corrected so many elements. In that one of the element is beryllium. Yes. So beryllium atomic weight is wrong. Compared with Mendeleev periodic table, previous periodic tables, this was Okay, corrected by in his periodic table. Which one? Beryllium. So answer is beryllium. Now next question. Anomalous pair in Mendelif's table is, yes. Actually Mendelif periodic table, yes, depends on atomic weight, that is called mass. But some pairs in his periodic table are anomalous. So what is the meaning of anomalous? Different. Generally, he said atomic weight should increase in his periodic table. But higher atomic weight he put first. Okay, compare with lower atomic weight. So according to his periodic table, it is the demerit. Like that demerit, some pairs present in Mendelic periodic table. Is it lithium sodium? No. So we know now lithium is higher atomic weight compared with lithium. So it is then wrong. So magnesium aluminium. Magnesium compared with aluminium has less atomic weight. So then it is wrong. So cobalt nickel. Actually nickel atomic number now we know 28. Cobalt is how much? Okay, 29. So atomic weight of the cobalt higher than nickel. But Mendel placed before nickel this cobalt because it is the demerit of the Mendelic periodic table. So this demerit here pair acts as a what? Anomalous pair. Yes. So this is called anomalous pair. So what is the answer? Answer is C here. Because this pair in the case of the atomic weight anomalous because high atomic weight is before nickel. So it is the wrong according to the Mendelic, but it is correct in this question because this pair is called anomalous pair. And beryllium, boron, they are proper, so it is the wrong option. So what is the correct option? Correct option is C. Yes. Now next question. Ecosilicon is now called as. What is ecosilicon? In Mendelic periodic table, Mendeleev was left some gaps. Okay, below silicon he was left one gap, but he don't know that element name. Is it gallium? No, wrong. Is it scandium? Wrong. Is it indium? Wrong. What is this? It is present after silicon only. This is called germanium. Yes. Why it is germanium? Because actually it is immediately after silicon present. So he was don't know name. So he was given for this element what? Ecosilicon. So ecosilicon later we came to know it is a germanium. But Mendeleev was very intelligent. He given proper place for germanium. Yes. That's why Mendelic periodic table given more information compared with previous periodic tables. Now next question. Next question is also related to JEE Mains. The modern periodic table is based on the atomic number. Yes, correct. Because modern periodic table fundamental property is increasing atomic number. So based on modern periodic table is constructed of the elements. The experiment which proved the significance of the atomic number was, yes. So given below some experiments. So which experiment related to the proved the atomic number? Yes. So is it Mulliken oil drop experiment? Mosley's work on X-ray spectra, Bragg's work on X-ray diffraction, discovery of X-rays by Röntgen. So Mulliken oil drop experiment is wrong, and Bragg's work X-ray diffraction related to electrochemistry, discover of X-ray also related to physical chemistry. So Mosley work, because Mosley he introduced work on spectra, X-rays, imitate some rays. Those are related to the atomic number. So mostly contribution is very useful contribution is experiment only given atomic number. So this is the base to the Niels Bohr constructed periodic table, that is called long form of periodic table. So Moseley's contribution here very useful used in the periodic table of the modern. So what is the answer? Answer is Moseley's work on X-ray spectrum. X-ray spectrum. So answer is 2. So next question. Yes. The element with atomic number 19 is. Yes. So atomic number, okay, 19. We don't know element X. So atomic number is 19. Now what we have to find out? We have to write its electronic configuration. Yes. So atomic number 19 electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, then 6, 7, 8, 18, 3s2, 3p6, 4s1. Yes. 4s1. Now we got here what? C. S orbital. Yes. So differentiating electron enters into the S subshell, that is called S block element. Clear? Now is it halogen? No, it is S block element. Halogen is a P block element. Is it chalcogen? No, because chalcogen also P block element. Is it noble gas? Wrong. It is not a P block element. So it is S which block element? S block element. So S block elements they divided into two. Valency electrons 1 alkyl metals, valency electrons 2 alkaline earth metals. So answer is an alkyl metal. So what is the name of this alkyl metal? Because we confirmed this atomic number 19 is alkyl metal. So this alkyl metal name is what? It is what? Potassium. Yes. Potassium, sodium 11, potassium atomic number is 19. Yes. So potassium is alkyl metal. More, okay, electropositive metal. Now next question. A pair of atomic numbers which belongs to S block elements. Yes, they given the pairs. First one is 715. So atomic number 7 means 1s2, 2s2, 2p, 4, 5, 6, 7, 4, 4, 5, 6, 7, 8, then 4, 2p3, yes, 3, 4, 5, 6, 7. So it is what? P block element, not it, okay. So this pair is wrong because it is P block element. What about 1s2, 2s2, 2p6, 3s2, 3p3s. So this also what? Wrong because both are P block elements. Now 9, 17. 9 is 1s2, 2s2, 2p6, 3s3, 2p, 5 P block element. So 17 also what? 1s2, 2s2, 2p6, 3s2, 3p 12, 3p7, yes. 7, 8, 9, 19, 3p5. So then this also wrong because both are P block elements. What about 6, 12? So electronic configuration 1s2, 2s2, 2p2. This also P block wrong. 1s2, 2s2, 2p6, 3s2. One only yes, but ask pair, then total option is wrong. So what is the correct option? 312 maybe because here 1s2, 2s1, yes. Okay, S block element because differentiating electron, last electron enters into the yes. What about 12? 1s2, 2s2, 2p6, 3s2, yes, correct. So last electron enters into the yes. So both option number 4, yes. The both elements they contain, okay, last orbit is S. So their element last electron enters into the S block elements. S block, S orbital. So both are S block elements. So both atomic number pairs they are S block elements. Clear. So next question. The element with electronic configuration they given yes. So electronic configuration given. So in that we take the 1s to 2 electrons, 2s to 2 electrons, plus 2p6 6 electrons, 3s to 2 electrons, 3p6 6 electrons, 3d10 10 electrons, 4s to 2 electrons, 4p5 5 electrons. Yes, clear. Last 4p5. Yes. So 4p5 means here, see, you take the every period number 1 that contain number 1 shell 1. Period number 2 contains second shell. Period number 3 contains third shell. Period number 4 is there here. So what is the shell? Fourth shell. So fourth shell means which period? Fourth period. Yes. So this element period is 4. Now which group? Question. So what about valency electrons? 7. Then it is 17th group, otherwise 7th A group. Yes. So valence electrons means last electron 7. Then it is 17th group or 7th A group. Now fourth, two options there. 5th period is wrong. Yes. 6th period also wrong. 5th period also wrong, because we got 4th period and 7. And we got the 4th period correct. 7th A group is correct. Yes. 7th period we did not get. We did not get the 4th group also. Yes. What is the answer? 4th period, 7th group. Yes. By this way, any element with the help of its electronic configuration, we can get easily its what? Period number, group number, because number of shells and number of period is same. But group we have to predict with the help of valence electrons. Clear? So answer is that option. Now see, yes, our Spark Academy, okay, exam wise previous year solved solutions also there. So that you join Telegram link, in that given link, yes, and check all solutions, get freely. Now our results overview. Congratulations to all the students. Okay, TS Eamcet 2021, the graph C 95%. As Spark Academy NEET 2021 results also, yes, the peak is increased totally. Yes, 2021 it reached 97%. Yes. Now some, yes, questions for you. Yes. Solve and post your answers in comments. The element with NS2NP4 as outer electronic configuration. Yes. So with the help of the outer electronic configuration, you find out, okay, the element is alkyl metal, chalcogen, noble gas or halogen. Yes. So next question. Solve and post, okay, your answer in comments. It is related to the atomic number, the physical and chemical properties of the elements, or the periodic function of their atomic numbers. Yes. This one stated by which periodic table, that you have to predict and post. So clear? So next. When a neutral atom is converted to the anion, yes, what is ion? What is anion? So atoms becomes anion cations. So charged particles are called cations, anions. When a neutral atom is converted to anion, what about its atomic number? Increases, decreases, or size increases, or mass number increases. Yes, that you have to find out and post your answer. Yes, so you have to post your answer. Yes, clearly. Yes. Next, see. So videos, playlist, communities also available. Subscribe to our channel and press bell for notification. You will get the notifications every day. So you will get the information regarding the entrance, okay, JEE Mains and what? Eamcet NEET. So here properties, see some examples they given sorted by Yes. So thank you. Okay. So here we completed today. So periodic properties of the elements in that. Okay. Mandelic periodic table. So Mandelic periodic table questions also there in our JEE Maths. So mostly the students they thought questions we will get only the modern periodic table, long form of periodic table, but questions available from the Mandelic periodic table also. So before we have to enter into the modern or long form of periodic table, we have to focus on Mandelic periodic table also. Okay, Mandelic periodic table, anomalous space, okay, demerits, and Mandelic periodic table groups periods also questions available. Yes. So thank you children. Thank you everyone.
పేపర్ పెట్టకుండా నా వేరే అనుకో ఇంటికి వస్తా